So we're gonna talk about functions. I'm gonna get rid of this stuff first, and we'll just do a couple examples of just writing some very simple functions, and then we'll bring back our P5 drawing and do some drawing with our own functions. So the main thing that we're gonna be working on today is creating our own functions. So we've obviously been using functions all semester. We have function setup and function draw. We use functions like ellipse and rectangle and circle to draw shapes and add colors. All of these functions are things that are provided to us by P5, by the library, or by JavaScript, the language. But we can write our own functions, and writing our own functions is a really easy way to do a couple of different things, which make it easier both to write code and to read our code. One is it's going to organize our code a lot better, and we'll see some examples of that. And the other is it makes it easier to repeat parts of our code in different places. So we can set up a function that does something, and then we can do it from our setup or from our draw or from a mouse click or from other different types of events. To first go over basically what a function is, functions are essentially just blocks of code or sections of code that we can call or run or invoke. There's a bunch of different terms for this, more than once. If we have like a series of statements that we want to use more than once, we can put them into a function, and then we just call that function instead of repeating those statements. So this is how we write a function. And what I'm going to go over now is going to look a little bit different from what we've used, how we've used functions so far in class. So when I want a new function, I start with the keyword function. We've seen that with function setup, draw, mouse pressed, etc. But when I write a new function, I can name it whatever I want. And I'm going to name it in a similar way to how we name variables, meaning that I'm going to use camel case. So I'm always going to start with a lowercase letter. And if I have multiple words, I'm going to capitalize the second and subsequent words. I'm also going to use names that describe what the function does. So the name of the function actually doesn't change the functionality of the function, but a good name makes it easier for us to understand what the function does. So I'm going to make a function called sandwich. And it's just going to say, just as an example, I'm just going to log something. I'm going to say I'm making a sandwich. So if this is all I have, this is a function declaration. So let me put a little note here. Or sometimes you call this a definition. So you're defining what a function does. And usually there's more than one line of code inside of a function. I'm just using one just for the example for now, but we'll add to it. So let's call this functions. So if I run this code, you're going to notice that when I open the console, there's nothing there. That's because I haven't actually called the function or run the function or invoked the function. So if I want to actually run this function, so run, there's a bunch of words for this. It's a little confusing, but to run a function, sometimes people say invoke. Invoke is like the proper term, but it's not a very common word. People don't use it for other things very often. So you can also say run or call a function. To do that, we just type the name of the function again, and then we have parentheses at the end. So when we define the function, we use the function keyword, and we create our code block in between our curly brackets that defines what we want the function to do. And when we want the function to run, we just use the function name and parentheses again. So if I run this, now you'll see the result. We get a log that says I'm making a sandwich. And I can do this as many times as I want. So you can see now it's done it twice, and I can do it from different places. So if I was running a P5 sketch and I had a setup function, I could also run sandwich. This is probably going to give me an error. Oh, no, it didn't. So now you can see I've logged sandwich 3 times. So once I define what I want the function to do, I can run it as many times as I want. So normally our function does something more interesting, like draw some clouds or draw some trees or draw a building. But for now we're just making a function that says I'm making a sandwich. So here I use the example banana, and we call the banana. So most functions, not all, but many functions have arguments. The arguments are also called parameters. Arguments change what the function does. So we've seen a lot of examples of that. For example, create canvas has two arguments, the width and the height of the canvas. And so when we create a canvas, we can do that here now. So these two numbers, 400 and 400, these are arguments or parameters. And this changes how the function works. So create canvas always does basically the same thing, although we can't see it right now because I haven't drawn anything on it. Let's do a background. There we go. So create canvas, the arguments change the way the function works, but the function always does basically the same thing. It makes a canvas, but it takes these two parameters or arguments that change the width and the height of the canvas. Same thing with background. Blue is an argument or a parameter. And so when we set the background, we're always going to be changing the color of the background, but the argument determines what color that is. So we can add an argument to our sandwich function. We could make a sandwich type argument, and we could add this in our string, or we can just make a new one. We can say console.log it is a sandwich type sandwich. Okay, so now we can add an argument to set the sandwich type. So we could make a bologna sandwich. Okay, so now we're saying I'm making a sandwich. It is notice that the first one is undefined, but our second one is bologna. So the reason our first one is undefined is because I didn't put a parameter here. So JavaScript is a little weird. In most languages, that would create a fatal error. So we'd get like some red text and our program wouldn't run. But JavaScript is like, oh, they forgot to put something in there. Whatever. We don't really care that much. So you may end up with, remember we talked about debugging, a conceptual gap where this shouldn't say undefined here. It should say something like bologna or whatever. But we don't get a fatal error. So that's something that you have to be careful for in JavaScript. This is actually, if you look, you'll notice undefined. If you're looking on a website and there's some like weird text, I've even seen this like, I had a meeting recently where you had to sign into the building and they print out a little name tag for you, and their computer printed out like some error code undefined. And so I was like, oh, some part of their computer system has a function that doesn't have an argument and it's printing out undefined instead of like what it's supposed to print out. So you'll actually see this like all over the place. It's a very common error. Anyway, that's what happens if you forget your arguments. So let's put our arguments in. So let's make a peanut butter and jelly sandwich.
The function on top basically puts in whatever you put inside the parameters.
Mm-hmm.
Switches it out. Can I see it? Can you scroll up?
Yeah. Hi. No, it's okay. I don't. Sorry. Yeah.
What's the difference between the difference between sandwich typing and parameters and just basically like naming the function?
You can name it whatever you want. I'm just using sandwich type to make it clear what the parameter is supposed to be used for. But it could just be type.
What's the purpose of sandwich type being within the parameters?
So I can change what type of sandwich. So I can make a peanut butter and jelly sandwich, or I can make a bologna sandwich.
Okay.
So the function does the same thing no matter what. It types or it prints I'm making a sandwich. It is a blank sandwich, but the parameter changes what type of sandwich it ends up being, at least when we log in the console. Does that make sense?
Yeah.
Cool. And, you know, we've seen a lot of examples of that, like when we draw a circle, we use parameters to decide where it is and how big it is, and we can change those parameters to match what we want for our design. So we can kind of think of a function like a blender. Blender always does one thing, it blends stuff together, but what you put into the blender can be different, and depending on what you put in, you'll get something out different. If you put in a bunch of, like, you know, fruits and vegetables, you'll get like some juice. If you put in, you know, some olive oil and, you know, nuts or something, you might get like a salad dressing. So the blender always blends, but the arguments or parameters are like the ingredients that we put in to get out what we want. This is another example where we have a couple of arguments. So we have a function that does a greeting. And so we can change the greeting, and we can also change the result of the greeting by changing the name. So let's do that one here. So I'm going to create this function called greet, and it's asking for a greeting and a name. And I think I actually reversed this. I did, but it doesn't really matter what the order of the arguments doesn't matter. You just have to be consistent. So for my greet function, I just want to log our greeting. So we're just going to say greeting, and then I'm going to put a little comma after that, and then put the name. And so again, if I run this code, nothing happens to start, although I have an error because I didn't put a plus here. There's no greeting. But if I want to run this, I can say greet, and I can have a greeting, hello, and a name, Jerry. And so now we'll see that greeting here. So we say, hello, Jerry. I can use the exact same function, greet, to say hi to Jenny. So we have hello, Jerry, hi, Jenny. So basic point is that the parameters that we put in can change the outcome of the function. Okay, we already talked about undefined. So we've talked a little bit about scope. This is another thing that's going to be important as we start to move variables around to different places and functions around to different places. Basically, the variables that we create inside of a function only exist inside of that function. Any variable that we want to be available to multiple functions needs to be outside of the function. We've already seen a lot of examples of that, but we can look at this one. So this is an example of some code that's going to give us an error. So I'll put this down here. So I have a couple of functions. One is assign, and the other is add. So in assign, I'm going to create a variable x, and I'm going to set it equal to 0. And I'm going to create a variable called y and set that equal to 1. So I can call assign, no problem. I'm not going to get an error. We see all the other stuff that we've done, but we don't see any errors. Everything's fine. But now in add, if I say x plus y, and I try to run that function, oh, and we want to log it so we can see it. I'm going to get an error here because it's going to tell me x is not defined. And if I wasn't trying to use x, if I was just trying to use y, it would tell me the same thing. So even though I've created these x and y variables inside the assign function, they only live inside the assign function. So they never make it to the add function, and so that's why we get an error here. So if I want these variables to exist, I need to create them over here. So I can say variable x and variable y. But these variables are still not going to be the same as these. So when I declare x and y here, I'm declaring x and y in the global scope, the main scope of my program. But then when I go into the assign function, one of the things that's kind of goofy here is that when I say variable x equals 0, I'm creating a new variable x that only exists inside of this function. So I'm still going to get an error, although I'm not going to get the same. I'm still going to get a problem, but it's not the same problem. So now I get nan. So nan isn't a fatal error, but it's not what I would expect the result of x plus y to be. I would expect the result of x plus y to be 1. So the reason here is even though I've created x and y, and I've assigned x and y, I'm assigning different x's and y's because I'm re-declaring them here. So what I really want, I'm going to comment these out. What I really want is if I just say x equals 0, this is now referring to the x that I created in the global scope. So it's a little bit confusing. We just kind of have to remember that that's how it works. There's nothing specific that tells us this x only exists in the global scope. It's another weird thing about JavaScript, but it's something that we just have to live with. So now I can assign x, and I'll be referring to this x. I can assign y, and I'll be referring to this y. And now finally, I'll get the answer that I was expecting, which was 1. 0 plus 1 is 1. So I don't think you'll have a ton of issues with this, but this is just something to look out for if you're using variables. Okay. So we're going to make some of our own functions in P5. I'm going to leave this sketch, actually, because there's a lot of stuff in here. So I'll just call this function examples, and then I'm going to make a new sketch. And what we'll do is we'll look at how to organize our code into new functions. So I'm going to add this to our class collection. And then I'm going to make a new project. And I'm going to call this drawing with functions. Any questions before we get started with these guys?
There was something that I was trying to replicate. I tried using like the sandwich type, but I got like an error.
Okay, I'll have to look at that when we're done with the lesson. Did you have a question? Yes. Yeah. There's some cases where it won't, but for the most part, yes. Yeah. Okay, so let's look at some ways that we can organize our code into functions. So we're going to be making a landscape this week, so I'm going to make my canvas a little bit longer. I'm going to draw like a little rectangle for some ground. Let's make a background that's light blue. And then I'll do a fill that's green. And then I'll draw a rectangle from 0 and let's say 400 to, let's make it width and 200. Oh, wait, no. That's too much. Let's do 300. Okay, there we go. Okay. And I'm going to say no stroke. Okay. So I'm going to make a little landscape. I've got some sky. I've got some ground. And let's add some clouds and some trees. So I'm going to start with clouds. So normally if I wanted to add some clouds, I'd make a little comment here. And then I'd start to do some drawing. So I'm going to fill white for clouds. And then I'm going to draw a circle, and I'll put that like here. And then I'll just make a few circles, and I'll kind of space them out a little bit. So maybe I'll put another one like that. Oh, that's too far away. Let's do... Okay, and then I'll do another one like that. Okay. Or maybe let's do... let's do one like this. Okay, so we've got a simple little cloud. So if I wanted to have multiple clouds, what I would probably do is just copy and paste and move all the X's over. right? And that would be kind of annoying and tedious. And if I ever wanted to make a change, I'd have to change every single parameter that I copied and pasted. So that would be annoying. Let's skip that for now and let's go to our next part. So I also want to make a tree. So for my tree, I might do like a brown color and draw a rectangle. Maybe at X is 100 and Y is 200 and width is like maybe 20 and the height is maybe 100, and maybe we'll add a nice little rounding to the corners. Okay, we've got a little tree. Maybe I'll move it down just a little bit. And then we want some leaves, so I'll do fill is green again, and I'll draw another circle, and I'll put it where the top of my tree is, so that's 100 and 220, and I'll make it like 40 pixels. And it's a little over to the side, so let's center it. So I'll put it at 110. And let's make it a little bit bigger. That seems like small for 40, but let's try 60. Maybe 80. Okay, so I've got a nice little tree. Same issue. If I want to have a bunch of trees, I'm going to copy all this code, I'm going to paste it, and then I'm going to change all the variables. And if I ever want to change the way that the tree looks, I have to update each one of those versions. So instead, why don't we make a cloud function and a tree function, and then we can call them and put clouds in different places. So I'm going to make a function called cloud, and I'm going to put this code in there, and then I'm going to call cloud. So it looks exactly the same, right? Nothing's changed except I moved the code from one place to another. But by calling cloud here, then I get a cloud down here. So one problem is, remember, we can call our functions as many times as we want, but if I call two clouds, it stays the same, right? Because I hard-coded the position and size of these circles. And so what happens is my cloud is in the same place, even though I am drawing it twice. So we'll fix that in a second. But notice now how much more readable this cloud is. This code is. I don't need this comment anymore because this function describes what it's being used for. It's very obvious that this function cloud is most likely drawing the cloud. So when you start to use functions and variables and other structures, our code becomes much more clear and much more easier to read. Okay, so our cloud looks good, but it doesn't move. So that's where we add parameters. And you're going to notice that our cloud function is going to start to look a lot like our ellipse, our circle, rectangle function. So if we want to change the x position, we can start with an x parameter. So I would put an x here, and then I would put different values in here. So let's put at 100 and 200. So we should see a cloud at 100x and 200x. So if x is 100, we can tell that that's just going to be the same number. So I'll just put x right there. But this 120 obviously is not the same as 100. It's 20 more. So I'll do something similar to what we did last week in our loop. I'll add to x. And here I'll say x minus 20. Okay, so now I have two clouds in different positions. And if I change the x position, my cloud moves over. Okay, so you can start to imagine how much more powerful this is because I can draw as many clouds as I want and I can put them all over the place. I can also change the y. So I don't have to. If I only want clouds on one line, I can forget about y. But if I want clouds up and down, I can add y. So my first y value is 100. Let's put 100 there. And my second one, let's make it taller. So let's go to 50, or higher rather. So now I just throw a y into the cloud. And for my first value, I just put y. And then again, this is 20 more than 100. So I'm just going to put y plus 20. Okay, so now I have a cloud that I can vary the y. So if I make this one 50, the cloud will go down. If I make it 50. So now I can draw my cloud design as many times as I want, anywhere I want to on the page. I can also change the size. I'm going to skip that for now, just to save a little time. But you could see that I could vary different things. I could add a color argument. So I could say maybe some of my clouds are not white. So maybe, you know, I have a white cloud here, but maybe I also have like a gray cloud. So then I could add an argument. I'm just going to call it C because color is a function in P5. And then I'm just going to, instead of filling white, I can fill C. So now I can change the color of the clouds as well. So anything that you want to vary, you can add a parameter for. If you don't want to vary it, then you don't need to add a parameter. Again, the order of the parameters doesn't really matter as long as you use the same one, but there are conventions. So you can see with P5, usually we have X, Y, size, or XY detail, XY, you know, usually we start with X and Y. Sometimes we have some parameter that comes first, like text or image, but usually we start with X and Y and then we follow with other parameters. But again, you know, you can choose what parameters you want to vary. All right, let's do our tree. And then the last thing we'll do once we do that is we'll set up a little loop so that we can, you know, increase our landscape a little bit. Any questions so far? Okay. So we have our cloud function. I'm just going to collapse that. And so I'm going to do the same exact thing. So I'm going to make a tree. And the first thing I'll do is just copy and paste all of this in here. And then I'll change this to just a tree. So it looks exactly the same because we didn't change anything. But now we can start to add some parameters. So we'll start with X and Y. So the X is 100 and the Y is 220. So I'll put those in. And then I'll replace X and Y here. And I'll replace X for my rectangle and Y. And then for my circle, I'm going to have X plus 10 to center it. And the same Y. Hey, how's it going? And, oh wait, did we get the Y wrong? Oh, I put 200 instead of 220. Okay, so now I have a tree. If I copy this and move over on X, we'll get another tree. And we can keep doing that. We can make as many trees as we want. So again, we can choose what we want to vary. Maybe for the tree, I want to change the size of the leaves. So I could make a size variable. So the leaves of my first tree are 80. So I could put 80 here. And maybe the next tree will be a little bigger. And so I'll give that an S for size. But I'll just put this in the circle here. And you might want to say like leaves size or something like that. It depends on how many parameters you have. If it's clear what the parameters are doing, then leave it. But if it's not clear, if there's multiple size parameters, then give the name something more specific. Yeah. Yes, so that's a very good point. So I didn't discuss that. So we were talking about the scope of the variables, and you'll notice that these X's and Y's that I'm using, they're not getting declared using VAR. When we create a function, one of the things that's convenient is that it basically declares the variables for us. So when you have X, Y, and S, you're essentially saying variable X. This is basically the same thing as saying like variable X equals 100 in the beginning of the program. But because it's a function, the way it's set up, since we can give it different parameters, it essentially declares those variables for us when we add the parameters here. So we don't have to declare the parameters. But if you wanted to have like trees in a specific place, you could have some, variable x1 equals 100, and you could put those parameters into, these arguments. That gets a little bit more complicated, and we're going to do something similar to that in just a second. Let me put a comment here. Okay. Okay, so our last thing that we're going to do is we're going to put this all into a loop. so that we can create a full landscape. And we can also do a little bit of randomness, but we don't want to take forever. So if I want to draw lots of trees and lots of clouds, I could continue copying and pasting this line, but even that will get a little bit tedious. So let's make a loop like we did last week so that we can repeat however many things we want. So let's make a for loop, and we'll start with x, and we'll start with x equals 50. So we'll start at 50 pixels, and then we'll keep going until we get to the end of the page. So as long as x is less than or equal to, I keep hitting the delete key by mistake, width, then we're gonna increase by 50 each time. So this is basically the same loop that we wrote last week. And now we have this variable x that we can use as our x parameter. So let's take one of our clouds and put that here. And instead of x, we'll have this x. Now our clouds are overlapping, so we'll fix that in a second. And with our tree, we'll put this x as our tree. So now we've got lots of trees, we've got lots of clouds. So I'm gonna leave these here, but I'll just comment them out. And look how much nicer this code looks. So when we were drawing our windows, we had these loops, and then there's all this crap inside the loops, and then we had to, go back and forth and look up and down. Now I have this loop, and it's just like I want to draw one cloud per column, and I want to draw one tree per column. And if I want to know what those are, I just look down here in my code, and I can see, oh, now I can make some changes down here. Okay, so let's vary this up a little bit because our clouds are overlapping a lot. So what I'm going to do is just make a random value for y. So I'll say variable y equals random, and I'll say somewhere between, let's say, 20 and 80, or maybe like 20 and 100. And I'll put that as my cloud y. Let's not, okay, we don't want it to go crazy. So I'm going to change, I'm going to take out, actually I'm going to change this. So since we're talking about making our own functions, if I want to call draw, but I only want to call it once, we can just change the name of draw. So I'm going to change the name of draw to landscape. So now it doesn't work until I'm going to call landscape from setup. So now we'll just get it once. Okay, so now we've got some nice clouds. I think we can actually make the clouds go a little bit lower. That's a little too low. They're overlapping our trees. So let's try 180, 160, 140. Okay, so now we've got some nice clouds. We can also randomize the color. So if I say variable C, oh, actually, I don't know if this will work. Let's try it. I don't remember if this will work if I do white and gray as parameters. No, it won't let me do that. Okay, never mind. Sometimes you can, there's other languages where you can do that, but not here. Anyway, we've got our clouds and our trees, and we could also randomize the size of our trees. So let's make a S variable that's random. Let's do between maybe 30 and 100 and put that there. 30 is a little too small. Let's do 50. And actually, let's start x at 0. I kind of want to fill this whole section. Okay, so I have some randomness. I have some controlled. We could randomize lots of other parameters. We could also, control lots of different parameters. But that's kind of the basic idea. This gets us started. So yeah, we have our clouds and our trees, and we can generate a landscape. And every time I run this, since there's a little bit of randomness, it's going to be a little bit different. So that's it for now. In the second part of class, we're going to add a couple of user interface elements so that somebody who's viewing this can click a button to generate a new pattern, and they can also click a button to save a pattern that they like. But for now, this is like the bulk, the main part of what we're going to do this week. So you guys can work on creating a landscape. You can put whatever you want into it. It doesn't have to be trees and clouds. It could be buildings. It could be outer space. It could be underwater. Whatever you guys want to do is fine. But just make a simple pattern that has repeating elements, essentially, and create a couple unique functions or custom functions to draw those things. So that's the basic idea. I'll add this to our collection. Or wait, that's the wrong class. This is our class. So if you want to make a copy of this and play around with it, you can do that. But that's the basic setup. So yeah, let me know if you guys have any questions. I'll take a look at your error, and I'll upload this video, and we can work on this for a little while, and we'll go over our user interface stuff at 4.